Okay, we have uh, came up to the step number 8 earlier. So in step number 8 we have to calculate the spacing. So here if we equate the moment of inertia about x axis and moment of inertia about y axis, then we will get the spacing between the I section. So here spacing between the I section, it means, so these are the two I sections and this is the spacing. So here we have equated and we have calculated the spacing between two I section, that is 280 mm. Now the next step is we have to design the batten system. So in the batten system, it means, so if we see these two column and we have connected these battens, so the capital C is the distance between center to center distance between the battens. So here we have to calculate first the batten distance. So the number one is the maximum spacing, the maximum spacing of batten, maximum spacing of batten C should be such that C divided by RYY less than 50. So C by RYY, this value should be less than 50. So here we have to calculate C. So C is equal to 50 into RYY. That is, C should be less than 1415. So calculate. So what is the value of RYY? Please see whatever section we have selected for this section. What is the value of RYY? Huh. What is value of RYY? Please go to the skill table. I think we have
28.4 mm.
28.4 mm for our selected section. So we have selected the section ISMB 350 for this 28.4. So how much this value? C value by calculation?
1420.
1420. How much?
1420.
1420. So it is, I think, greater than 1415. No. Just a minute. Okay. So second condition. What is second condition? So second condition is C by again RYY is less than 0.7 into lambda E. So calculate 0.7 into lambda E. Lambda E is, I think, 58.98. Correct? So how much this value? And this C, calculated C is 1420 divided by 28.4. So this is the calculated C divided by this and 0.7 into this. How much this? It means we have to calculate this, sorry, this value we have to calculate, C value here. So this is not here we have to put. This is the second condition. 0.7 into this value, how much? So this is zero point 0.7 into 58.98. So C is equal to again 0.7 into 58.98 into huh, how much this? 0.7 into 58.9, how much? Into 28.4. कोण बोलतंय आणि आवाज येत नाही असं होतंय का मला? ओके 1168. हाँ 1168.84 and it should be less than 116. This is 1.95. So here we can use this value of C, this. So this is the correct now. So this value we can use instead of this. So this condition will be satisfied. So here we can use 1168.84 less than 1594. First condition we have to satisfy this. If not satisfied, then we have to go this condition. So we can use this now. So 1168 is the less than value of this 14. 1415 पेक्षा ही व्हॅल्यू पण लेस आहे आणि सेकंड कंडिशन पण सॅटिस्फाय होते ना. So this we have to use this C value 1168 and again this value we have to again round off this. It means here we have to use this C is equal to, so we have to assume this C value as 1168 only, no problem. Yeah ma'am, are you getting? लक्षात आलं का? पहिली कंडिशन सॅटिस्फाय नाही झाली म्हणून सेकंड कंडिशन, दोन कंडिशन दिलेत आपण. सो सेकंड कंडिशन गॉट सॅटिस्फाय and this value again, this value less than this value, so we can use this C value, this 1168. So write this. Okay, so now in step number 2 what we have to calculate?
Horizontal length.
So we have to calculate transverse shears to be registered or other. What we have to, horizontal length. Oh, sorry, horizontal length we have to calculate. So horizontal length of batten. So horizontal length of batten is equal to, see, horizontal length how to calculate? These are the two eye sections. Okay, so this is the S distance. So if we provide this S, or we can add BF by 2 here or BF by 2 here, or S plus we can add here G and here again G. So this is S, so we can add here G and G also. otherwise bf by 2 or bf by 2 anyway. So here we will add s plus g. Okay, so here assume, we will assume g is equal to again 40 mm here. So horizontal length is s is 280 we have assumed. So calculated. So 280 plus 40 plus 40.
360.
Jitendra Patil, you please mute yourself. Jitendra Patil. So what is this 260?
360.
Sorry, 360. This will be 360 mm. So this is the horizontal length. So if we add s plus g, or we can add s plus bf by 2 plus bf by 2. Means for full length we can provide the batten, or s plus g. So we can assume g value in between 40 to 50 mm. So here we have assumed the value of g is the 40 mm. So for both side, here 40 mm and other side 40 mm. So 280 plus 40 plus 40, 360 mm is the total horizontal length of the batten. Okay. So next, okay, next is the transverse shear. Okay, one of the question I got from the your side, if we add the bf, it means bf by 2 bf by 2, the value will be changes here. See, if we add bf by 2, it means bf length is what, 140. So here 70 plus 70, so how much it will get? I think 420.
420.
Okay, no problems. As last lecture I have told you, if this 420 is the greater length we have assumed, here we have assumed batten length is 360. If the 360 length batten will carry the column load, no problem. But if not carry, then we can provide this. म्हणजे 420 सुद्धा आपण प्रोव्हाइड करू शकतो, किंवा 360 पण प्रोव्हाइड करू शकतो. मी लास्ट लेक्चरला सांगितलं 420 प्रोव्हाइड केल्यानंतर इथं काय होतंय, 420 जर mm आपण लेंथ प्रोव्हाइड केली तर व्हॉट विल हॅपन, ऍडिशनल लेंथ ऑफ प्लेट वी हॅव युज्ड. हे 420 हे ऍडिशनल आहे. आपण मिनिमम किती प्रोव्हाइड करू शकतो, एस प्लस जी प्लस जी, एस प्लस जी प्लस जी. दिस वी कॅन ऍड मिनिमम. 420 जर आपण ऍड केली ते म्हणजे काय असणार आहे, तर या फेस पासून इथल्या फेस पर्यंत टोटल डिस्टन्स असणार आहे. चेंज काही नाहीये, फक्त एक्स्ट्रा प्लेटची लेंथ तुमची इथं होते जर बीएफ बाय 2 ऍड केलं तर. आणि 360 ऍड करायचं म्हणजे काय, एस प्लस जी, दिस इज द मिनिमम रिक्वायरमेंट. सो वी कॅन यूज दी एस प्लस जी ऑर दिस ऍज यू विश. ऍज अ डिझायनर, तुम्ही जर डिझायनर असाल तर ते तुमच्या विशनं ते दिलेले डिझाईन असेल, कुणाचं ऑब्जेक्शन असायचं कारण नाही. आर यू गेटिंग? यू कॅन यूज एस प्लस जी ऑर दिस एस प्लस बीएफ बाय 2 प्लस बीएफ बाय 2, कुठलंही तुम्ही घेऊ शकता. फक्त चेंज काय आहे, बॅटन प्लेटची लेंथच तेवढी चेंज होणार आहे. बरोबर आहे का? इथं चेंज काय होणार आहे तुमचा फोल प्रॉब्लेम मध्ये, फक्त लेंथच बॅटन प्लेटची चेंज होणार आहे. दुसरं काही प्रॉब्लेम येणार नाही. ओके, सो यू कॅन यूज दिस और दिस, and in this way 280 plus 40 plus 40, so it means 360. Okay, so we have here taken s plus g plus g, that is your assumption as a designer. Okay, next, transfer shear. Are you getting, Sonali?
Yes, sir.
Transfer shear resisted by batten. So that is Vt. So again, Vt is the 2.5% of factored load. Vt is the 2.5% of factored load. So 2.5 divided by 100 into factored load is 1800. So calculate Vt transverse here.
45.
45. Okay. Okay, correct, 45. So 45 kilonewton is this transverse shear registered by the batten. It means horizontal force. तुमच्या कॉलम वरती किंवा त्या बॅटन वरती हॉरिझॉन्टल फोर्स किती येणार आहे, तर 45 किलोन्यूटन इतका येणार आहे. देन नंबर 4. What is number 4? Longitudinal shear we have to calculate now. So now longitudinal shear resisted by batten. Vb is equal to, longitudinal shear is nothing but Vb. So Vb is equal to Vt into C divided by N into S. So this is the formula for longitudinal shear. So now calculate, put the value Vt. So Vt is 45. C, so whatever we have selected or calculated C, how much? 1168 divided by N. What I told, number of channels or number of I sections. Here 2 I sections are there. 2 into S, spacing 280. So tell me Vb is equal to, is in kilonewton again, because longitudinal shear force is there. How much this?
93.86.
93.86. 93.86. Okay, so this is the longitudinal shear. It means actually vertical load is more coming on the column than the horizontal load. So horizontal is the transverse load and longitudinal is the vertical load. So here along the length, it means along the length load is coming on the more on the column. So that is 93. So that's why batten carries the 93 kilonewton load. The load coming on the batten. हा batten वरती येणारा तुमचा लोड आहे. ऍक्च्युली हे तुमचं काय आहे, आय सेक्शन्स आहे. तर हे याच्यावरती काय होणार आहे, तुमचा टोटल हा एफ असतो लोड 1800. आता तुम्ही काय केलंय, इथे बॅटन्स बसवलेत असे समजा. तर या बॅटन्स वरती काय होणार आहे, तर हा 1800 पैकी जवळपास 93.86 इतका लोड हा बॅटन वरती म्हणा. म्हणजे याच्यावरती येताना ही बॅटन इकडे ट्रान्सफर करणार, इकडून आला की ही बॅटन इकडे ट्रान्सफर करणार. सो लॉन्जिट्युडनल along the length, this is the longitudinal, along the length the load coming is 93.86 on the batten, because we are designing and calculating the forces on the batten only. Okay, now next number 5. Okay, so what is, again we have to calculate movement. Next point, we have to calculate movement arising from the transverse shear. Movement arising from transverse shear. So we have denoted to movement as M. So M is equal to Vt into C divided by 2N. Okay, so again VT here. So VT is the 45 into C. C is the here 1168 divided by 2 into 2. So how much moment? It is in Newton. Sorry, C is the mm. We have to convert into हे किलोमीटर म्हणजे आपण ह्याला काय करू मीटर मध्ये कन्वर्ट करू see this 45 is in kilonewton but this 1168 is in mm so here we can put dot 1.168 meter are you getting 45 into 1.168 meter means now it will be इथं 1.168 घ्या कॅल्क्युलेशन मध्ये 45 into 1.168
13.14 kilonewton meter.
correct kilonewton sorry here I have written newton 13.18
14.
13.14 kilonewton meter correct if we convert into newton meter so newton mm like this into 10 raised to 6 okay this is related to movement now number 6 design of or size of batten sorry size of batten so for that we have to provide first number of sorry size of bolt so here we have to write provide 20 mm आपण किती चा यूज करूया हां how much diameter of bolt we use त्याच्यापेक्षा कमी
16 mm.
हां कमी करूया आपण तेवढं जास्त लागत नाही 20 mm चा so we will use 16 mm diameter bolt of 4.6 grade use करू आपण 4.6 grade okay so we have to first design the end batten so we have to first calculate the size of end batten here size of end batten size of end batten okay in the size of end batten what we have to calculate first see the procedure effective depth of end batten so d dash is equal to so if this is the I section and if we provide the batten like this then here bolts are there and so this is S this is G and this is G okay so D dash what I told what is D dash so D dash is the center to center distance between end bolts 3 bolts असतील तर दोन्हीच्या एंडच्या सेंटर टू सेंटर डिस्टन्स आहे आणि small d is the overall depth of batten okay so D dash how to calculate D dash as a D dash is the S plus 2 into CYY S plus 2 into CYY so yes is 280 mm plus 2 into CYY value of I section.
$28.4. Sorry.
28.4 आपण कशाची व्हॅल्यू घेतली होती? RYY घेतली होती. CYY CG ती रेडियस ऑफ गायरेशन होती आणि CG चे डिस्टन्स. CYY ची व्हॅल्यू असेल का? नसणारच आहे. Why? For I section, CYY value will not be there. Why? Because CG त्याचा कुठं आहे? एक्झॅक्टली y ऍक्सिस जो आहे इथं CYY, पण चॅनलचं कसं होतं? चॅनलचं CG इथं आहे ऍक्च्युली, त्यामुळे हे डिस्टन्स वेब पासूनचं हे डिस्टन्स त्याचं CYY असायचं. हे डिस्टन्स CYY असायचं. तसं आय सेक्शनला CYY ची व्हॅल्यू येणार नाहीये. So here wait 2 into CYY. So here CYY will not be there, so we can use here directly yes instead of CYY. Because this is for not applicable for I section. So here yes only, and again this yes value it should be greater than 2 into BF. So how much yes value? 218, correct? So 2 into how much width of flange? I think 140. So it is again 280. So actually 280, 280, it should be greater than, it means 280, no problem. So here D dash is equal to 280 mm. We can provide this. That is the effective depth. Then small b, overall depth of end batten. So overall depth is small d here. So this is d dash plus 2 into edge distance, correct? So here we have to calculate edge distance. So edge distance is equal to, how to calculate edge distance? Edge distance small e is equal to 1.5 times dh. So 1.5 times dh is nothing but 1.5 into dh is the what is diameter? 16 mm. 16 plus we have to add 2. So
18 mm.
18. So how much E?
27 mm.
27 mm. So calculate overall depth. So overall depth D is equal to D dash 280 plus 22 into 27. So how much D? 54. It means
334 mm.
34 mm. So small d is the 334 mm. It means overall depth of batten. means we have used the depth is 360 and we have width is here used 334. Are you getting? The thickness काढायची आपल्याला याची. Okay, now small c, thickness of end batten. Thickness of end batten, that is t. So how to calculate thickness? T is equal to 150 into horizontal length. So which horizontal length we have used? So 150 divided by horizontal length is 360 we have used, correct? S plus G we have taken. So how much thickness is there?
7.2 mm.
7.2 mm. So we can use this 8 mm. Now here if we use the 420, जसं की म्हटलं BF/2 जर ऍड केलं तर 420 होणार, जर 420 केलं तर हे वाढणार आहे थिकनेस फक्त. सो डिपेंड्स अपॉन लेंथ वरती ती डिपेंड आहे थिकनेस. And here small d, again length of batten that we have already calculated, length of batten, that is L is equal to S plus G we have taken, so that is 360 mm already taken. Otherwise at top you can if you not calculate this length of weld at top, then you have to calculate here and then thickness, like way you can also calculate. Okay, so here we have to provide the dimension. So provide length, how much? 360 by width is 334 by thickness is 8 mm. So provide 360 by 334 by 8 mm size of end batten. Are you getting? So this size end batten we have to provide. Are you getting? So easy, only we have to follow the procedure. And okay, then capital B, size of intermediate batten, size of intermediate batten. So in that again we have to calculate first depth of effective depth of intermediate batten. Same जे चारी वरती काढले तसेच इकडे काढायचे, फक्त थोडेसे फॉर्म्युले चेंज आहेत. इफेक्टिव्ह depth of batten, intermediate batten. So what is formula? 3/4 into overall depth of end batten. So this is the formula. So effective depth of end batten means D dash for the intermediate batten. Sorry, effective depth of intermediate batten, that is D dash is equal to 3/4 into overall depth. So overall depth we have calculated for the end batten. So 3/4 into overall depth, how much? 334. So calculate here effective depth of intermediate batten.
250.5 mm.
So 250.5 mm. So here we can provide greater depth but not use less depth. So here we will take round figure, that is D dash is equal to 252 mm. We will take 252 mm. 250 चे आपण 252 करू. Now overall depth of end batten, sorry, intermediate batten. So overall depth small d is equal to again d dash plus 2 into edge distance. So d dash is the 252 plus 2 into edge distance is 27. So how much?
306 mm.
306 mm is the overall depth of intermediate batten. आणि अगोदरची किती आली होती 334. Then number C. फास्ट होते का, हळू जायला पाहिजे का? म्हणजे फॉर्म्युलेच आहेत पाठीमागं तुम्ही लिहून घेतलेत, तेच मी फक्त, कारण का आपण फॉर्म्युले डिटेल एक्सप्लेन केले होते. सो दॅट्स वाय आय एम गोइंग फास्ट. Similarly, end batten, this is the intermediate batten. Now thickness of intermediate batten. So small t is equal to, again here 1 by 50 into same formula, 360. So here again 7.2, it means 8 mm we can use. So we got the length, width, it means depth, and thickness. So here we can write provide length is 360 into width is 306, that is depth, into thickness is 8 mm for intermediate batten. So this is the size for the intermediate batten. It means end batten we are using at top and at bottom. 8 meter length of column is given. So for this 8 meter length we have to provide the, so if you draw this sketch here, see, so this is the (8 meter) column depth. Okay, now here this is the, it means it the sketch we will draw at the last, because number of bolts till not known to us. इथे number of bolts माहित नाहीत आपल्याला.